Hey everyone, welcome to the community office hours. I'm Mark and I'll be your guide today in packaging a package with tea. And for this, we're going to use the new and improved packaging framework with BrewKit. And I'm heading over here to the Pantry Extra repository on GitHub, specifically the contributing guides, where you can see the step-by-step process of how you package, create, package, and contribute your submission. So first of all, I'm gonna clone a, a fresh version of the Pantry Extra into my demo folder right here. I'll cd into Pantry Extra, and then I can see basically all the packages that exist in Pantry Extra by just like ls projects. And these are all the packages in Pantry Extra. Right now, we have these two pantries set up, Pantry Extra and Pantry Core. Pantry Extra is where the community contributions and most of the packages go into at the moment. And because there is much more contributions than there are in the core packet, in the core pantry, we have decided that pretty soon we might merge these two pantries actually, because we were actually a bit ahead of the time when we wanted to kind of decentralize all the pantries. The code will still be there to decentralize the pantries, but for now we see that most of the effort goes into Pantry Extra. So we want to have all these pantries here, and yeah, that might make it also a bit easier with like looking up, does this package already exist? So because it happened to me last week that I packaged like two packages that were already packaged. So that's my fault, but yeah, I hope that won't happen to anyone else. So yeah, with like ls projects, you can see all the pantries in the packages in the Pantry Extra here, or you can also search them on GitHub, obviously, or there's a new command that we released with BrewKit called pkg search. And with pkg search, you can basically search any binary. So let's say I want to search if Node exists. It's downloading BrewKit into kind of like this t-out scratch file, scratch repo. So that just might take a moment. Why is it doing this? It's because we are in this Pantry Extra, and we don't want to use our local T installation, but a separate T installation where everything kind of gets installed to, so that we can basically run infinite amount of like T directories locally and T versions locally. In this case, I have my I'm just gonna show you. So I have my local T installation at like the default .t directory in my home. And now we also have kind of like a T installation, which installed T right here in our working directory of this Pantry Extra. So that's kind of neat. That means that if you're packaging, you're not polluting your local environment anymore and installing these binaries in here, but you're installing them all in here. And what I did here with pkg search, it basically showed me, okay, there's the package name called Node.js, the binary is called Node, and this is the version that we have packaged. That's the latest version. What we can also do is we can do inventory. So if you're interested in, what kind of packages or package versions exist for Node.js in T, we can run this and we can see an output of all the packages or package versions that have been packaged. So, the LTS for kind of like version 14, 16, 18, and the latest one with 19. So that's also neat. And that searches across all pantries that have been merged. So it doesn't search, obviously, for any packages that are currently PR'd or have not been merged yet. So only those that have been actually uploaded and are in the pantries. But it's neat if you, for example, ever forget, what's the fully qualified domain name of a particular binary, or if you want to search for particular versions of a package. So I thought that was very neat addition. I think Max added it last week. Okay, cool. So I'm in my pantry extra. Now it's kind of like, so I'm just going here through the contributing guide. There's like these various commands that all stem from BrewKit. So BrewKit, for those of you who haven't checked it out yet, it's its own package, and it basically extends Key with like various infrastructure commands, such as you saw, whether it's build, edit, initialize, but also test. So it works with all these packaging keys that we have in the packaging YAML, or in the package YAML, and also search, inventory. I think these are the ones, yeah. And so basically, if we don't know yet what the package that we want to package is called, we can just call package init, and it will create basically a random key qualified domain name. And we got to change that later before we pull request, open a pull request. But right now you can see here, it created a package YAML file, is in this like work in progress Kenyan, which is, I guess, a random style of T. And it created a default package YAML. I can now call package edit, and it will open up my local text editor, which is VS Code. Everyone has their own, what they prefer. And it adds this like default template where, it's very verbose, and added a lot of commentary. Just added a lot of commentary for, just like if you're getting started and you just don't know what all these different keys mean. But for now, I want to add a particular package. So how do I go about this? Because I always find it easier, like searching for a package first that doesn't exist yet, and then start packaging that. Already initializing it with the full qualified domain name, and then it'll be a lot easier. So the easiest way is kind of like, we have this like top 300, which you've seen me mention everywhere. I think I can either click on that label here, or just like browse through the list. And usually there's a lot of libraries in here still. We are going to add another 300 packages that are much more that are not just libraries, but of course libraries are also core kind of like to packaging. They're reused in a lot of other things. And to make things easy, I hope, I think I picked one of these packages called Opus. And what you can see here when you click on one of these packages, so this is within the top 300, and I've added here like a homebrew formula. So when I click on the homebrew formula, it kind of like, because packaging in a way is like a lot of redundancy, right? Like each ecosystem has its own set of instruction sets, how packaging works. And Homebrew, has a massive amount of packages already in its ecosystem. So, and everything is obviously open source, just as, all the T instructions are open source. So we can have a look at, how is Opus, and Opus is an audio codec. It lives under this like domain here, opus-codec.org. And we can look at kind of like how the Homebrew packaging code actually looks like. For those of you who don't read like Ruby or not familiar with Ruby and the syntax, it's actually not so difficult to read. Basically, you want to look at kind of like, for us, what's important is you want to look at kind of like the depends on command here. And that basically tells you, okay, what dependencies are there. And I can see right away, okay, this is using like autogen and configure and make install. So this is like a C kind of like built tool chain. And it's using autoconf, automake, and libtool only for the build process. And as you can see here, with like by indicating this build, if this like arrow build doesn't exist, let me just Lino, can you mute yourself real quick?
Oh, sorry.
Oh, good. Yeah, so if you don't see that like build tag here, then they would be runtime dependencies. So they would go into a different key. So what I'll do here is I'll take kind of like the full qualified domain name, opus-codec.org. I'll head over to my pantry extra. Let me clear this out. Let me actually remove this project work in progress because I don't need that. This is what we just created.
I think your video broke up.
And now I'm just gonna package init and use opus-codec.org. All right, and it's
for me too.
Tells me, okay, it's created a project, opus-codec package YAML, and I can either do package edit and then opus-codec.org, or package edit is smart enough to understand what changed in our Git, and if there's not two changes, right? If you initialize two packages, then it will not work. But if you only initialized and changed one package or initialized one package, then you can just hit package edit and it will open whatever package you just created and it changed. And that's going according to the Git. I'm actually going to delete all of this here because it's like, it's too much green and like it bothers me. Makes it hard to read for me. And the first thing that we want to add here is kind of like the distributable URL. That means, where do we get the tarball from? With the source code that we can. Are we still? Do you still? You should see my VS Code now.
Yeah, now it's updating.
Yeah, it's fine.
Okay. Sorry for the delay. I hope that's not any problems in my internet connection. But yeah, please like interrupt me if there's like anything freezing here. So I'll find a distributable for this particular package. Like, so I can see here already that Homebrew is using kind of the archive.mozilla.org where it's hosted for Opus. I'll typically always check GitHub if it exists. Not sure if that's the same one. It seems like it's the same one. So this is updated. So the latest release is in 2016. Let me double check. So it seems like this version on Mozilla is newer than the one that was on GitHub. So okay, seems like they didn't tag a release in here. That's interesting. So they only tagged this release 1.1.3, but they actually have a tag with the version 1.3.1. That's fine by me. I can, as long as I know, okay, this is the latest version, and it's kind of aligns with, what is on Mozilla. And then I feel pretty confident to take the source code from here. And what I'll do is I just copy this link, obviously right click the tarball, and kind of like paste it in here. You'll see that, it's like archive refs, tags, etc. And then the version number prefaced with like this V for version. Yeah, hopefully that's in somewhere. And so it has like these like 2 dots basically, and 3 digits. And then because we specify everything in Semver, otherwise there's other workarounds, and we'll go into that later on. So we have other keys, for example, like version major, which gives you kind of like the first digit, version minor, and version patch. So all of the 3 Semver digits we can get like this. And there's also version raw, which gives you kind of like whatever we get from GitHub. But typically, if they follow Semver standards, then this shouldn't be a problem. We can see here that it's v1.3.1. What we do here with versions, one of the benefits of using T is that we automatically fetch the latest version as they get released or as they get tagged. And that's why we have like a sub key here called GitHub. We have 3 different ways of fetching versions. I'll typically use the tags kind of like path here. And then this basically goes, if you want to understand more what it does here is, and why it's like such a weird path, it's because in the background it's actually using a GraphQL API to like follow this path to basically all of these tags, and then they get sorted based on date, and we take basically the latest Semver version that's released here. Because we get the version like as a whole, so like v131, we want to strip the v from it, because in T, as you may have noticed, we are listing the v as well, but we kind of want to strip that out in order to process that. So here are the 2 kind of like dependency keys. As a first level key called dependency, that's the runtime dependencies, whereas the dependencies that are kind of like 1 level below, either in the dependency or in the test key, those are dependencies only for the build process or for the test process. Sometimes here we might fetch, in the test that we're writing, we might fetch something. We might have to add a C compiler in order to run a C script. In any case, we basically have these here. So we have a C compiler, we have make, kind of like out of the gate. If you're not using a C build chain, then you can delete those and replace them with whatever you have. Maybe it's Go, maybe it's something else. This foo.com obviously doesn't exist. We don't have a runtime dependency. We can double check that. Again, here we have basically only build time dependencies, so libtool auto make autoconf. If we don't know what these are called out of the box, I don't know why this doesn't automatically go into the correct. Okay. So if I don't know what are they called, I can search autoconf. Yeah, this is an issue. This is not actually an error. It's just it wasn't saved, and there were 2 GitHub keys, so it was confused. Which is there can only be 1 GitHub key for obvious reasons in this YAML. Otherwise, it's incorrect. However, this is a current like packaging issue. However, we see the fully qualified domain name is autoconf. Can just like add to GitHub Copilot auto suggests auto make. That's kind of nice. We can double check this, and that's correct. So these are my 4 dependencies, and then I have libtool as well as a package dependency. So I'm searching this. If it's too small, I can make it a bit bigger. Now it's a bit cramped for me, but it's hopefully good for you. Okay, so libtool is also under GNU. Maybe GitHub also suggests that. That's great. Yeah, I noticed GitHub Copilot is like really useful for like knowing dependencies for some reason. I don't know if it understands that I'm, because I already have autoconf, that it understands, okay, if you have autoconf, typically you have automake and then libtool, or if it like actually understands the URL and infers, okay, this is a C project and that's why I need it. I don't know how smart GitHub Copilot is, but it definitely helps. Okay, over here, we are kind of like, there's no configure executable shipped with the kind of like with the code, with the tag here. That's why we kind of have to create that with autogen. Sometimes in a tarball, we can omit the autogen because there's already a configure, but this is very C specific. It's not going to hurt to do this, but sometimes it's redundant. In our case, we need to do that. And then, yeah, one of the most important things, and for some reason, this is not included here. We have environment variables for our build pipeline, and you can see this with $args here. This you can obviously name anything you want. This is just a variable name, and the variable name is reflected here. But we're calling arguments, and then you can list as many as you want that you want to pass into the configure. Typically, for the C build pipeline, we need to kind of like configure the correct path, and prefix is another variable that's provided from T, same as the version. And prefix basically is the prefix inside of T. So where the package dependency lives with that particular version, and it's the entire path, like where this directory lives. And this is just abbreviated with prefix. And so when we pass this into configure, we make sure that this will be the directory where everything will be installed to. And then we have kind of like this hardware concurrency, which basically just uses all the available CPU cores that we have. And then finally, we do make install. And just to double check, there is a bunch of other flags here that Homebrew adds. And, if we're fancy, we can just add those as well. Disable dog. Let's just add those. Probably will save us a bit of bandwidth. All right. Okay. So the next thing is you want to run this, and how you do this is basically opuscodec.org. So you will specify again the full domain name. In this case, it's a simple one. Sometimes there could also be a package that doesn't have a qualified domain name, and it just lives on GitHub, and that's like kind of like the main page. So we would use we would use a different qualified domain name like GitHub and then whatever package name. But wherever there's a domain available, we want to use it. All right. So hopefully it doesn't take too long to build. So what it does, it's fetching all the different tags, and you can see here that it kind of like has two types of tags. So it's reading the latest tag as V131, and it's outputting 2T131 because we're stripping the V from it. Then it's downloading the tarball. It's installing all the dependencies that it requires. All of these go into T out. Nothing goes like locally. And then it basically kind of like goes into this prefix. So this is the prefix. This is where the source directory is being installed to when we download it. And let me see if it's so hard to read all these environment variables that are being exported. So here's basically our first line of the script, so autogen. And then here configure, and here you can see the prefix actually at its fullest. So P again is adding this V in front of it. And we're adding all these other kind of like flags to the arguments in configure. And it does that and does what it does. It's checking everything. I have 12 cores, so it's running the job on the install process on 12 cores. And then finally, there is the make install, which is, and if there's no error, then it worked, and you can kind of like see what happened in the end. And if we kind of like open the out Opus codec. Okay, this I cannot make bigger for some reason. I hope it's big enough. So we have like these different like two main directories and three kind of like links. This is our source directory. Oh, this is ugly if it's so big. This is basically the entire source directory that we downloaded, plus our kind of like autogen script on it. And here's kind of like what's included. So there's no actual binary for Opus codec because it's a library. So we have an include with all the different C headers. I hope that's not too small for you to see. We have the dilibs, and we have another like shared directory. And that's pretty much the end of the building process. We can remove this provides key because there's no actual binary that is output. Now we want to build a test script in order to actually test the library, because tests are key and are required in order for us to merge packages into the pantry. Yeah, David, I just saw your question. Yes, you can also run package build without the domain. It will just understand, again, as it understood with kind of like the git diff, what packages have changed, and you can just like run package build. I still love like adding the like specific package name, but yeah, that's personal preference. The variables for the package YAML, they are listed somewhere, but they could be more prominent. I agree. So they actually live under pantry 0, but I will move them over to the package extra. So here are basically in structure of a YAML, and I'll just post this in here real quick. In structure of a YAML, of a package YAML, we have here all the different variables, so to speak. I guess the versions is missing. There's also an interesting dependency. If, for example, you want to add a shared folder to another package from a different package. So let's say you have a dependency, like a runtime dependency, for example, on one package, call it like foo.com, and you want to add the library actually of foo.com to in your build process here, and like kind of like there's a tag kind of like that a flag that points to the shared library. You can add the that specific folder in these arguments here via a variable. So it's just printing the path to that particular variable, and like fills it in. I can search for a package that I may have packaged where this is the key. Let me finish the test here first, and then I'll get to that. But I think that's also something that I found just by doing it, and actually GitHub Copilot auto-completed that particular variable for me, and that was quite funny, I thought. Yeah, so for the test, I could like think of like a cool test, or I could just like copy the test here. I'm not that well versed in C, so yeah, this actually makes life a lot easier. So here, what happens here is we have basically a particular, code with like int main, where we then like use the opus.h header library, and then down here, what we're doing is we're like running this file and executing this test. So what we need here, first of all, is we need some kind of like C compiler in order to run this. Then we have another key called fixture, which is basically, how do I explain it? You can put basically any type of like code in here. And so here, like GitHub Copilot auto suggests some like command, which is actually quite funny. But I'm basically pasting in this code here. Let me just format it real quick. I'm a stickler for this. Yeah, and fixture outputs also a variable. So what I do here is, yeah, it already, like, GitHub Copilot is going crazy. It like wants to do something here already. What I do is I move fixture. Doesn't understand everything. That's interesting. I can just put it into CPP. And then I CC and then fixture CPP. I'm basically running this. This is like too much. I don't know why. Does it want all of this? Interesting. So I guess it does. So it adds the include opus, the library. Let's run with this. But I want it out to test. Or
and Mark, you shouldn't need the include or lib.
That's what I thought. I never included this. Yeah.
Right, because T specifically, when it sets up the environment, includes the LD flags and C flags environment variables. So all that stuff. Well, you will need to link in the library. That you will.
Yeah. I need.
And just so you know, if you don't include an output flag, A out is the default. So you only need it if you want to run a test.
Interesting. That's cool.
But yeah, that should be a perfectly minimal test.
Great. Thanks, Jacob. Yeah, it's interesting that GitHub Copilot suggests this, like including all the include file and lib. But yeah, basically, so I can run pkg test, or again, let's just run pkg test, and it adds an error. That's interesting. Why it doesn't find that particular file. Let me just double check. I have everything in here. So that's the live show. Interesting. Is there a way to like output everything that's being used in C? And
yeah, the C flags environment variable when you run the test should show you what it's got. So C path. So you see the C path variable there points to the include directory. So I'd make sure that the opus.h lives in the include directory. If it doesn't, it's possible. This is something we see a lot with some libraries. It's possible it's a subdirectory down, in which case what you can do is move all the files a level up, and then yeah, see, it's include opus.h.
right. Okay.
So one of the little packaging tricks you can do is at the end of your build script, you can move everything in include opus to include, and then link include opus to include. Yeah, it's easier in practice than it sounds.
So move everything up one directory, basically.
Yeah, and just create a symlink so that things that expect the subdirectory aren't confused.
Yeah. Okay. So the symlink would be in the opus directory, right? Not the include will have all the files directly,
Right, so,
and then the opus will have the symlinks.
I'll put it in the t-time text directory what I'm talking about.
That's nice that Jacob's here. Jacob's always the lifesaver. Yeah, so could I?
So something like that. And you can do the same thing for library files as well if you find that it's making a library subdirectory.
Right. Okay. Got it. Okay. And
well, don't forget the symlink, just so you
yeah.
still have. Yeah, there you go. So basically, you see that just moves everything up a level. So if you have something that's just including opus.h, it finds it based on the C path, which is just the include directory. And if you have something that's referring to opus/opus.h, that will still work as well.
Okay, but what I could have done also to fix it, I could have just put opus/opus.h, right?
You could, but other programs that just try to include opus.h and expect to find it in the CPath will have the same problem. So rather than having to patch everything, you can just be clever with how the headers are arranged. And like I said, we sometimes do the same things with libraries. Ncurses is famous for doing this, and some things want to find ncurses.h and some want to find ncurses/ncurses.h.
Okay, makes sense.
Oh, haha! You have to remove dir, and that you have to remove the actual opus directory before you can create the symlink, or pass -f on the ln call. But you're basically trying to overwrite it. I think just adding -f. Yeah.
Yeah. Makes sense. But it does.
No. Yeah. You just need to do a remove dir of prefix include opus before you. Well, since it should be empty, it's much safer to use rmdir.
Okay. Yeah, I had a discussion with Max, or not discussion, we were just talking about it, that, yeah, I always use rm, like recursive, instead of rmdir.
Right,
okay.
Right. So the thing about the safety that rmdir gets you is that it won't remove a directory that has anything in it.
That has something in it.
We want to make sure that there's nothing in opus that helps protect us.
That's
So
good.
now,
Good
now
thinking.
your package test will probably work. Hopefully work.
Yeah. Package test should work now. All right. And it did work. Cool. So just to kind of like see where this goes into a separate test directory as well, with kind of like here this like test.sh bash file, where our instruction set is kind of like everything is put in here, and then we just execute that script. So this is our fixture C++ file, and then the cout. Yeah. Okay. So right now we have kind of like this untracked files. Just want to be thorough here. Go back to the steps in the contributing guide. So we've done all of this up to the test. Another thing that's not mentioned here, because we are supporting 2 platforms at the moment, and in the future more. There's also BrewKit includes a flag for testing and building on Linux. That is, so right now I'm on a Mac machine. I have my Docker kind of like locally, my Docker desktop running, and I know everything works now on kind of like on a Mac machine, but I want to also test it on Linux. So all I put is like kind of like this -L in front of build, and then it will basically spin up a container for Linux specifically and run everything in this Docker container. So it does all the installation. I'm just gonna real quick. Cool. Yeah, so it's installing everything there. It's like slightly slower, but shouldn't be too slow. Interesting. Oh, okay. Yeah, there's something, I think version 6 of BrewKit is broken, if I'm not wrong. So let me see if I can kind of use the different versions. Let me see what versions of BrewKit exists. Can I switch PKG? Would be interesting. Testing. Okay, I cannot. Inventory BrewKit. Oh, I guess it's txyz/BrewKit. Okay. Let me use the latest version here. txyz. I have actually not done this, so this will be interesting to see if it works the way I thought. So all it does is it should basically fetch this particular version of BrewKit, because BrewKit 06 seems to be broken at the moment. At least there was something going on in the chat. Opus codec. Let me see. Interesting. Build not found.
I think it's because it's not passing through your version specifier to Docker, so you're ending up with 6.0 on Docker.
Oh, maybe. Is there a way to clear that on Docker? Do you know off the top of your head?
You should be able to remove the package from your Docker mount point that you mount the packages to. Yeah.
Okay. Let me just do this. Huh.
Yeah, that's the problem.
Okay. Let me
There's
think.
a 7.0 that was pushed. Let's see if that should have built.
Does that mean that CI is also broken right now?
CI, I believe Max pegged it to 0.5.x until rootkit issues are resolved.
I'm thinking, can I? Maybe I should put t-pantry path, change t-pantry path in front of it if I want to patch that particular.
I mean, Brewkit doesn't have any binaries, so honestly, you could just remove the 0.6.0 Brewkit from your T Linux and copy the 0.5.2 one from your regular T. That's a bit hacky, but it should work.
Interesting. Yes, it has this one. Yeah, let me see if that works. Just copying it like this. I should probably copy it properly. Let's see. This is interesting. Oh, I deleted it already. Too bad. Can you copy entire files, or do I need to preface them with -r? Brewkit. No, just copy the Brewkit over.
Probably gonna need a -R
Yeah.
for recurrent, but that should do it.
Right here. Oh, okay. Yeah, that's stupid. I did a mistake here. Interesting. But copied the entire.
Copied it a level down.
Yeah, exactly. Okay, well, this we complete. Let's see if this works then.
Well, don't forget to remove 0.6.0. Otherwise, it will just use the latest version.
Even if I specify this version?
You can locally, but what I'm saying is I don't think it passes through to the sub invocation in.
Oh, okay. Okay.
Which is painful and is probably something that should be handled, but certainly not trivial.
I guess this I didn't. Okay. Let's see what happens. Now I wanted to show you how it works on Linux, and doesn't work the way I intended it. Yeah. Is it because these are still symlinks of version 6? Might be.
Yeah.
No. Let's see if this works. No. Okay. I don't want to waste your time looking at how I'm trying to debug this. Normally, if there's no broken version of Brewkit, then this will just work fine, and the same with the test command. It's probably that, I don't know, Brewkit already has that version installed on Docker for some reason. I don't know. I restart Docker, maybe that works. Does it clear any?
Well, it should be shutting down after every command, so.
Yeah. Strange. Okay. Anyway, let's assume it also works on Linux, and you've tested it locally. Then we want to add kind of like a fork of whatever we cloned here, because we cloned obviously the main repo. So we can do that with the GitHub command line tool repo fork. It will see that the fork already exists, ask me to add a remote. In case you haven't forked it yet, it will offer you to fork it and add the remote after that. So I want to say yes, add the remote. And if you just want to double check, like I always want to double check, you can see that the origin is now set to my fork and that the upstream is set to T's pantry main repo. Cool. Next, we want to open obviously a new branch, because that's just good etiquette. And always move the branch. I know there's like a different flag here, M. I've actually never looked into what the two flags do differently between M and B. Maybe does it automatically merge? I don't know. In any case, it doesn't really matter, because this does the same job. So it creates a new branch, and that doesn't exist yet, and it moves everything over here. Yeah, and then I can kind of like just commit this add opus codec, and then I'll push it up to the origin called opus, and then I can from the command line, I know there's a shortcut, I always forget it, PR create. I always like hit that. Set default, which repo should be the default viewing creating pull request. Push the branch to my branch. I don't know why it asks me this if I just push the branch. I guess the GitHub command line tool doesn't really know what Git is doing. In any case, I typically like to, so you can obviously leave out this like -w, and it will just give you a kind of like a form to fill here in your terminal. I like to kind of add it from here. And then I can add this like tag closes opus, because we have this like open issue here. And this is kind of like smart of GitHub, right? If you closed or closes or closed by, if you add that to one of your comments here, it automatically closes the issue when the pull request is merged. So yeah, I open the pull request, and then a few seconds later, the CI should start running if it's not currently busy. And then I don't know how long it takes typically, but this package shouldn't be too big. And the build process and test process would run in parallel for platforms. So Mac, kind of like x86 architecture and the AMD architecture, and so the Arch 64, and then for Linux the same. So in this case, Intel and the M1 chips basically for macOS. Yeah. So build process is underway, and yeah, that's pretty much it. That's the entire process of picking a package to committing one. And Will can just like let this run. But if you have any questions, I'd love to.
There's one thing. There's one
I think
additional step
Jacob
that you
would be best
that
equipped
you-
to answer this. Like, what's our M1 builder?
Yeah. I mean, we've got a fully loaded Mac Studio.
In the
that's
CI.
running. Can you hear
I
me?
think,
Cool.
yeah, I think he bugs out. You're talking over each other.
Yeah, sorry. Yeah, we've got a Mac Studio that runs the AR64 builds, with the M1 Max or M1 Extreme, whichever freaking chip it is. So, but Mark, I was going to say the one other thing that you might need to update in your package YAML is if there are any binaries provided by the package you've packaged, your provides key should reference those. And we may have lost him. And yet we can still see his screen.
I should be back now. I hear everyone now.
Yeah, we can
Mhm.
still see your screen, but now we can hear you.
Yeah.
Yeah, I don't know. Was it the screen that kind of like froze?
No, because
That-
we saw you Slack me.
yeah.
Yeah. Okay. Let's see. Yeah. So the last few tests are running, and then this is also done. Should be green checks. Also on Linux, even though we couldn't test it locally.
What are the jobs that are being skipped?
These are the jobs that are running once we like initialize the merge, as far as I understand. So we're like bottle means we're actually kind of like uploading like so we're using the binaries and then upload them to our storage. But yeah, Jacob, you probably know more.
So in an effort to make everything, not have repeated code and be, the same on package build and package test and everything else, the build.yaml is it's quite complicated, and it's got a bunch of subtasks it does. So for example, a new version produced from a GitHub tag goes through roughly the same process as a commit in order to ensure that everything builds the same, everything looks the same. It just has other steps that run. So it's just a difference of where it's being run, which steps get pulled in, so that it all goes to the same. It's complicated. It's a lot of GitHub Actions nonsense. But we've been refining it for 8 to 10 months at this point, so it's pretty solid unless we break something, which sometimes happens, like with Drukit.
Yeah, thanks for the explanation.
Yeah, no problem. So Mark, I don't know if you heard me, but I was saying the one other step that that might be in the process of building the package is if it provides binaries. Obviously, you'll want to know which binaries it provides and include those on the provides key so that the magic works as expected.
Yeah, absolutely. You're 100% right. Let me pull up. Just a different, like a project that has. Let's use the GitHub CLI as an example. So actually, for like shits and giggles, I could just package. I mean, you can also package like any package that exists here. It's redundant, but if you want to understand and you want to learn kind of like how this all works and like why it works, it's actually a good learning exercise, I found. And especially like for maybe like build pipelines that you're not so familiar with. In general, looking at package YAMLs like of different languages is quite interesting. Like for example, here we have just different environment variables that we're setting. We have environment variables kind of like subkeyed to a specific platform for Linux here, for example. And I think these are like small things that right now, as of today, are not yet well documented. They're kind of like documented within these like package YAMLs. So yeah, for example, like the NP for particular packages. This is something that I think is valuable to know. Yeah, I can look at so right here in what Jacob means, right? We have this like provides key, and then we for the GitHub CLI, there's only one binary that's being output. But what we can do is typically if you run, let me just out CLI GitHub and then version 2.0. Yeah, so typically you would have only kind of like right now we have one binary, but there's other packages that have multiple binaries, such as I think Little CMS has multiple binaries. Yeah. So Little CMS, it's this color management library, and also has some. It's mainly a library, but it also has these binaries. So here, for example, yes, we have multiple binaries. And if you don't know what these binaries are called like ahead of time in the build process, it will put everything into kind of like the right folder. So into CLI. So in here into like for the GitHub CLI in version 2.24, and then bin. And yeah, if there's like, oftentimes I don't know what the binaries are called, so I just like copy whatever is here in this binary directory, and then you can paste it here, and just make sure you add the correct path to it, like bin in front of it. But yeah, here, for example, I'm adding like dependencies just for the test because I'm using wget. We do have some fixtures, as Max told me last time, for like 1 pixel images, which I didn't know. It's like somewhere here in one of these packages. But we'll be better in like documenting like all of these. But yeah, basically it's helpful to look through some of these packages, like what they do and how they work, how they're built. There are some packages, for example, that use CMake. And if you look at the install instructions, they would tell you to do something like this, like make dir build, or like, sorry, make dir build or build, and then cd build. Well, we have a key that kind of abbreviates all of this, which is called working directory. And you could just name that working directory here. And then all the work, in particular for CMake, will happen in this work directory here. that's like small hacks, I guess, that you learn over time as you're like packaging and finding things. So Sanchit, one of our team members, he started packaging something recently and realized that, or I think after Jacob or one of the team members told him, he could just use this working directory key that comes in quite handy. What else? Are there any other questions? Anything that you guys want to know? What are some other kind of like hacks that I have come across, or things that were obvious once I've seen them, but not obvious when I was working through them?
Package
One of the
YAML
things-
is not the only file that we can use. If we have multiple files that we might need for testing, we can put them alongside package YAML. They will be available at build and at test.
Yes. Let me see if I have an example here.
And the same thing is true of the build directory. So the build directory gets access to the package YAML and anything alongside it in a props subdirectory. So a lot of times you'll see us applying diffs out of props / whatever the diff has been named. When you test, they all end up in the same directory. It's a bit of an inconsistency, and we're considering changing it so it ends up in props on both for consistency. But of course, then we have to go through and audit hundreds of recipes and update them just for that one fix, which is a bit of a pain, and that's why design decisions can stick with you forever. But yeah. You can definitely include files that you might want during build or test alongside your package.yaml, and available to you when you're building and or testing.
Yes. And the fixture key is just kind of like a way to create that like virtual file, I guess. You could also just create a test.c file in the same directory and put that code there. It worked just the same. It's just nicer that everything is, especially if this code is not too long. It's just nice to have it all in one package, in one file instead of looking to two files. But for some things, like, for example, if you're testing a image library, it's sometimes helpful to do it on an image.
I think GCC under GNU.org has a bunch of test files and possibly patch files as well.
Right. But are they here? No, I don't think they're. Oh no, there is GCC under GNU. Yeah. So GCC has 2 test files for C and C++. And a lot of binaries. And so this is the way you could, I guess, implement it as well. There's no way to do a fixture with because like both of these are not really long. Technically, you could probably put them in a fixture if it was just one of them. But I guess because there's 2 and there's like only one fixture key, right? You cannot put 2 there.
Right. We don't have like an array of fixtures.
Yeah.
That could be useful in terms of like visual representation, but the ability to add files directly, and honestly, it means that like your test files will open up in a code editor the way you expect them to. If you have a test.c file, VS Code will let you know. So there's benefits to both approaches.
Yeah. I guess having both is like having files, like being able to add files alongside the package YAML is definitely should exist. That's why it exists. So that's smart. What else is there? Is there anything regarding documentation that? Oh, I wanted to show you maybe if we include a package from a different path from a package. I don't remember exactly.
Check Amazon, aws.amazon.com/CLI.
Okay. Amazon. Oh yeah, perfect. Thank you, Jacob. Yeah, so basically we have this dependency Python, and in the C path we're adding the prefix of the dependency python.org, which is kind of like the dependency. So this is what you saw here as this like deps key, deps variable. Yeah, but we can just go deeper and deeper into it. So python.org, it's a bit confusing because of all the dots. You just need to be able to read kind of like that python.org is the fully qualified domain name. And if it would be longer than python.org, so like Rustline Cargo, then it would literally just be that entire key here in here. And then dot prefix tells us where this particular package is located. And then we can use all the files or directories that are in there. What is the version.marketing key?
It's version major version minor.
Okay, so it's avoiding the patch. Okay.
Yes, because Python sub keys everything off of like Python 3.11, Python 3.7. So that's the marketing version.
That's helpful. Yeah, I saw that a couple of times and I wasn't sure. But that's cool. I guess this is that's actually something that is not correct anymore. It should be version here. Something that I can change after this call. And here's actually the explanation. So major, minor. Okay, I guess I was thrown off by the build. Or sorry, by the prefix. Yeah, what else? What else is there? I guess what's also new is this, like, now that we have it here, this Python venv virtual environment.sh. I think that's interesting. That helps with a lot of the Python development. I don't know actually where this lives. I'm just gonna search. Okay, so it's part of Brookit. It lives in Brookit, and it's a bash file, but it creates a virtual environment. So when you call that script with, in this case, prefix bin AWS, you could as well kind of like create all of that from scratch, but we're saving you the time. And if we let's go to AWS. Just have a look at that. I have so many tabs open, it's like sometimes confusing to be able to read. So why does it work for us here? Because we have kind of like a setup.py right in here. So it needs that in order to, so it can create a virtual environment anywhere, but it can only install, like pip install everything in the source directory if, a setup.py is given or some other config file. And then it does that, creates a bin, and creates a executable file with the name that you pass in. So in this case, AWS. That's the file that we're that's the name that we're passing in. That's what the binary should be called. And yeah, in here it kind of like does all of that. I try to understand everything in detail, what it does, but basically it looks for kind of like the tease Python and the virtual environment, and then executes or makes it executable, the AWS, and makes it executable here. And so this is like how most of the Python packages can be built. Sometimes there might be some tweaking. It's not a perfect script, but it definitely works. Which was Jacob, do you remember which was the package that we had to loop around because it had like
Yes, it was the
directory,
the Azure CLI
on Python.
Yeah, it was the Microsoft Azure CLI.
I guess I don't hear anything.
You don't hear anything? Can you hear me now? Hello.
No. No, it's also C.
Can you hear me now?
Yeah, there was a package that I don't remember it anymore.
Yeah, I think it was Azure.
Azure. Microsoft. Yes. Thank you. Thank you. Perfect. So Azure is a bit different than AWS in their setup. So in their source root, they don't have any config file for Python. Instead, they have they have these different subdirectories where all the config file lives. So core CLI and just CLI. So what we needed to do, at first I thought, okay, we can't use this like script because it doesn't really work. But it turned out that we can wrap this into a loop and then just loop over the different directories. And that was super helpful. So that we could also build this.
And the only reason to do them back to front that way is to ensure that the main Azure CLI ends up as the final binary. So it basically builds the VNVs back to front so that the main one ends up as the last one created and ends up with the actual script.
Yeah. Yes, correct. Yeah, that one was a fun one. I'm actually working on an example script using both AWS and Azure because I find the binary names very funny. AWS and AZ. I think that will make for a good script, like downloading from one, uploading to the other, or something like that. Yes. GNU Telnet. Yes, Telnet. I also had a look at Telnet. Can open this. What's happening? Oh yeah, that's the dependency for GNU Telnet. I think inet utils. Cool. All right. Sorry. Yeah, Magnus, I'm just reading your question. Okay, PKG edit works. That's great. Fantastic. Package telnet. Depends on Xcode. Yeah, Jacob, correct me if I'm wrong. If there's a dependency on Xcode, that is implicit by T, so you don't actually need to specify that.
That's like 80% right. So if there's a dependency on Xcode, that generally means a dependency on the compiler, in which case you use the txyz/gx/cc version C99. And what that does is that on Darwin requires that you have the Xcode CLang compiler, and on Linux installs LLVM/CLang. So that ensures that we're building with LLVM and CLang on both environments, and in general tries to make sure that everything gets set up correctly. And it also that CC helper does a few other things. It's got some shimming logic to handle R paths and a few other things, so that stuff comes out consistently. Literally, we just changed it maybe last week to enable pick/pi on Ubuntu, because Ubuntu enabled them 7 years ago, and building without them was causing some seg faults for us. So, yeah, that's a helper C compiler that basically wraps around either system LLVM/CLang on Darwin, or wraps around LLVM that we install on Linux. If you specifically need the Apple Xcode CLT for some reason, there is a key for it. I believe it's apple.com/xct/CLT maybe. You search for apple.com, we'll find it. Xcode/CLT. If you look at the GCC package.yaml, it specifically requires the CLT because it needs the macOS.SDK. So that's basically a virtual requirement.
Nice.
Ideally, you don't require that specifically, because general purpose is general purpose, but not everything is perfectly general purpose in that way. So
That makes sense.
Yeah.
That's actually, I guess, LLVM requires it. GCC, yeah. Those are mainly the packages that we have. Okay. What else can we show? Is there anything else, Jacob, that you would say would be interesting to know?
There's just a lot of tricks being done in various package.yamls. Packaging is as much art as anything else. Packaging modern stuff using the Go C compiler or Rust, which is a personal favorite of mine, tends to be very, very, very simple. Whereas some of the antique stuff like GNU.org packages, configure and make
try and keep things simple, but it's not always the case. And then you get, your really low level stuff like your Haskells and your Pythons, where, they don't expect people to be casually building and installing them. So they are, very, very specific in how they're configured. You can find examples of all sorts of things sprinkled throughout the package.yamls. It's just a matter, I guess, of if you get stuck, ask for help, look around and see what else is being done. Seg faults on Linux is a fairly common one. Like I said, we implemented a trick in our C compiler shim that should dramatically reduce those. Obviously, Gob packages tend to need something specifically passed, like Mark showed you. It's a lot of fun when you finally wrestle a package in submission and get it building reliably across 4 different platforms / architecture pairs. And it's it's frustrating when you're stuck in the middle of it, and you're playing whack-a-mole where every time you change something you fix one thing and break a different thing. So
yes. I just thought of another thing. So I mean, these hacks obviously super important, because only that way we learn how to build for different languages. I just made a note for myself to kind of like pick, like, for each language. I mean, we have Go, where there's like a mod file, but there's also Go where there's like no mod file. We have Ruby. Oh, click on the wrong one. We have Ruby, obviously C, Rust, Python, etc. I'll pick one of these for each language just to give like examples. Put that on the packaging documentation. I think that will be helpful for people to like see how it's done, that it's not so intimidating in the end. What's the proper way to package a Python package with multiple binaries? Here's a hacky solution. Ansible. Okay.
Basically, you can't see it here, but when Python builds a binary, right? That binary is actually, also Python script that points to, like, what are the VMs and what is the expected Python distribution. And then T copies it and does a bunch of magic, with the T prefix, T VMs, stuff like that. And like the Python VM, the default script, right? It only creates one binary by default that you can see, right? So in this build script, right, if you go to line 19, right,
Yep.
I just go over all those binaries. You see they live in VM, prefix /VM, and we need to move them to prefix /bin.
Yeah.
Yeah, so a more complicated Python package might not be specifically handleable by the script, but yeah, for example, this links out each binary. Again, things like this these tricks get developed on a case by case basis. It would be very, very interesting to see a modification to Python-VNV that actually looks at the binaries completed and makes the appropriate scripts at the end. That would be a huge improvement. It's Python, I would say, outside of Haskell, which I have not touched in months, fortunately, is easily one of the most frustrating in terms of how it works. Partly just because Python uses virtual environments like we do, so when you're trying to wrap a virtual environment in a virtual environment, you start to run into some things where you question your sanity, right? Like things aren't simple because we're trying to make it simple and they're trying to make it simple. And when you try and make it simple, you add complexity on the inside. So, you're just stacking complexity at that point. But yeah, Ansible's this looks like a great example of one way to do it. Yeah. I mean that looks like the potentially the right way, and something that it would be nice if Python V&V did for you.
Yeah.
Cool, thanks.
Yeah, that's a good example. One other thing that I've come across because I've had that issue myself is you're packaging something and you find out, okay, like Opus was easy. If we look at Opus, right, it didn't have, well, all the dependencies that we needed already existed. However, if we look at like Minikube, it's like a easier Kubernetes CLI that helps you run Kubernetes clusters locally. There are Go, obviously we've built, and here it's also sometimes Homebrew like has a different naming convention than we would have them. Sometimes they would name it like the binary. Sometimes they would name it differently. So Kubernetes CLI, for example, if that's a tricky one, I guess. Here it points basically to Kubernetes, right? And you can see that by the GitHub URL. If you searched in package for Kubernetes CLI, you wouldn't find anything. But if you would find kubectl, you would find it, and that's exactly the same package that kind of like Homebrew is packaging. So that's like a tricky one with like searching and like knowing different things. So that's why I always suggest if you can find it here and like, but you sure like, oh, this should exist already, and you maybe it's already ticked off in the issues. Sometimes we're not so diligent with adding this closes or closed by in the pull request, or we just forget. Well, it's just human. And yeah, you can just like search in here for, I guess, Kubernetes, like across the org, and then you see that, okay, this is already packaged and it's using the same GitHub directory or repo as the one that's specified in Homebrew. So there's like these minor differences between Homebrew and GitHub. But that's actually not what I wanted to show you. What I wanted to show you, and let me see if I can find it again. I don't know. I'm here. Again, too many. Okay, here. Yeah, Go bin data. That's something that we have not packaged. It's just like a smart utility tool. So this is basically a Go package. It's not been packaged yet. Can't find it anywhere in our search, and I can't also find it anywhere with our GitHub search. So what happens is that you might want to go ahead and package this package, and then you PR it, but it's not yet merged, and you have the issue that originally you didn't want to package Go bin data, but it's just a dependency that you needed to create in order to package Minikube in the end. So your goal was Minikube, but you had to go out of your way to package something else. That happens. It happens less and less. I found as there are more packages, the more base packages we cover, and the more exist already. In this case, we were only missing one. The other day, I started packaging this Facebook package called Watchman, which I only noticed because I've seen it a lot used in other packages. It has a lot of dependencies, and one by one I was working them off. And so what happens if you PR it, but it's not merged yet? It will not actually be able to be fetched from the pantry directly. And the hack or the workaround, if you want to get started, it works for you locally, right? You package Go bin data locally, and you want to go start Minikube without waiting for one of us to review the pull request. You can, right now I only have kind of these two local branches, but let's say one of them was Go bin data that actually contained bin data. I don't know. Let me just create a random package name. So this is here. What I'll do is let me just commit this so that it stays. This is not good practice what I'm showing here. Don't do this at home. Yeah, in any case, so I have, let's imagine I have a Go bin data packaged under this branch already. It works, it runs. And now I want to do Minikube. So I'll create my separate branch and I merge Go bin data in here. That's necessary even if you build it and let's say open out. So let's say Go bin data is here. So it's actually under I didn't build it obviously because it's under W work in progress. Matcha. Oh, it's nice. It's my favorite tea. And the binary is here. So the package is here. And you have to merge in that particular package in here. Sorry, that particular branch with the package YAML for that project in order for the pantry to understand, if you adding it as a dependency in your build dependency or runtime dependency, doesn't matter. If you add Go bin data as your build time dependency, you need to have the package YAML in that same pantry. So that's why we're doing a merge. And then once you're ready, you've packaged Minikube, you can kind of undo the merge. So you basically, that's what I've read at least online. I'm sure there's other ways to kind of find the last point in time before you merged. But you can see here, the last thing I've done was merge Go bin data. This is this particular ref. So I would go to the previous one with git reset merge, and then just paste this one in here. And what you can see here is that, well, I should have showed you this before, but what you can see here basically is that the work in progress directory with the package YAML for Matcha is no longer in here. Before that, it was in here. And you can see that in git ref log also that. Oh, sorry, down here. Yeah, you can see here that we moved to a different ref. So, and then you can go ahead and merge it, and open a pull request. If you don't do that, you kind of merging two packages with one branch, which is not the end of the world, but it's like not clean. And I actually don't know what happens if the CI can understand that or not. But yeah, I always kind of like revert or reset my branch to before I merged all the different dependencies locally. And then, the CI should just wait until the packages are available.
You can base branches off each other so that you have access to the packages.
Yeah, you can rebase. Yeah,
it gets a little tricky, and it can, depending on what it's trying to build, it might think that there should be a bottle available and fail. But in terms of just building your trees of package YAML files, yeah. And the cool thing about GitHub is that if you base a PR off of a different branch, when that branch gets merged, it updates your PR to point to the merge location. So you can literally stack them up. Obviously, some of them might not pass until everything else is merged, but they can all depend on each other, and then their PRs will update to wherever the branch gets merged to when they're merged. So that can be useful when sort of working ahead of the merge process.
Interesting. So then the merge is actually just like so super rudimentary. I could like rebase this Minikube branch off of the GoBin data branch, basically. Okay, that's interesting. Yeah, I'll typically add these. So if there's dependencies, I'll add these in there just to check. Like, okay, these like require libarchive and libtonica, which I had previously submitted. And then here I can see obviously that they're merged, or hover over them and then see that, I guess I cannot see it just by this little icon that they're merged. And then, yeah, I can basically then hopefully the CI would pass. For this one, it still doesn't pass, I guess. Or does it? Oh, this passes. Okay, that's great. Yeah, Doxterm is the one that doesn't pass. It doesn't have any dependencies, so that's great. Yeah, cool. I think that's about it. We're closing in on 2 hours. That was a great session so far. Anyone else have any question while we're still here? If not, thanks so much for attending. It was a pleasure. Thanks, Jacob, for being here the full 2 hours. And yeah, Alan as well. And of course, everyone else, Edgar, Bitcomfort, Lino, Keith, Magnus, Anastalita. Cool. Yeah, very good session. I hope that it was not too boring. A lot of code, but that's what packaging is. And yeah, I think next week I'll think what we can do next week if we're gonna do an AMA. Kind of like if there's something new that we'll share. Until next week, I'm sure there'll be maybe there's a version 0.25 of the CLI coming out. Maybe. I see a lot of activity on there. But yeah, if there's any input from you, you can also like just leave it in one of the chats, general or packaging or so. There's different places. Cool. All right. Then I'll just stop sharing my screen. I'll stop recording. I recorded locally, so as with the AMA last, 2 weeks ago, last week was, we were at like East Denver. That's why the time zone and everything, even though it's probably closer to the US, where some of our friends are. Yeah, missed that office hour. But that's why we did a long one today, and then next week, an AMA session. Yeah, and then I'll upload the video, including the recording, local recording, plus the audio, on YouTube, and share it here with everyone. All right. Thanks so much. That's it from me, from us. Thanks for the response. Seems like everyone liked it so far. And yeah, catch you on different channels, in Discord or on GitHub or on Twitter. Thanks, Jacob, also.
Thank you. Of course.
All right, I'll just leave this on and stop recording now. Turn off.